Hi everyone, welcome to my channel, Yosmos Space Exploration is my passion, a place that answers all your space questions. I'm your Yosmonaut, Yash Mittal. Why don't you buckle up as we launch this episode? Forces. Rockets are great examples of how forces make things move. It's a common mistake to think that rockets move forward by pushing back against the air. And it's easy to see that this is a mistake when you remember that there's no air in space to push against. Space is literally that empty space. When it comes to forces, rockets perfectly demonstrate three important scientific rules called the laws of motion, which were developed about 300 years ago by English scientist Isaac Newton. First, a space rocket obviously doesn't go anywhere unless you start its engine. As Newton said, still things like rockets parked on launch pads stay still unless forces act on them, and moving things keep moving at a steady speed unless a force acts to stop them. Second, Newton said that when a force acts on something, it makes it accelerate, go faster, change direction, or both. So when you fire up your rocket engine, that makes the force that accelerates the rocket into the sky. Third, rockets move upward by firing hot exhaust gas downwards, rather like jet planes or blown up balloons, from which you let the cold air escape. This is an example of what's often called action and reaction, another name for Newton's third law of motion. The hot exhaust gas firing down, the action creates an equal and opposite force, the reaction, that speeds the rocket up. The action is the force of the gas, the reactions, the force acting on the rocket, and the two forces are of equal size but pointing in opposite directions and acting on different things, which is why they don't cancel out. The force that pushes a rocket upward is called thrust. It depends on the amount and speed of gas that the rocket fires and the way its exhaust nozzle is shaped to, to squirt out that gas in a high pressure jet. When a rocket's engine to squirt out that gas in a high pressure jet. When a rocket's engine develops enough power to thrust, force pushing it upward will be bigger than its own weight, pulling it down. So the rocket will climb into the sky. As the rocket climbs, air resistance will try to pull it back too, fighting against the thrust. In an upward climbing rocket, thrust has to fight both drag and weight. This is slightly different to an airplane, where thrust from the engine makes the plane fly forward, drag pulls the plane backward, and the forward motion of air over the wings generate lift, which overcomes the plane's weight. So a key difference between a rocket and a jet plane is that a rocket's engine lifts it directly upwards into the sky, whereas a jet's engine simply speeds the plane forward so its wings can generate lift. A plane's jet engines fire it forwards so its wings can lift it up. A rocket's engine lifts it up directly. The faster things move and the more their shape disturbs the air, the more drag they create and the more energy they waste uselessly as they speed along. That's why fast moving things, jet planes, high speed trains, space rockets, and even leaping salmon tend to be long, thin, and tube shaped, compared to slower moving things like boats and trucks, which are less effective by drag.